Okay, so this is the key to section 1.4 part 1, and on this worksheet you're adding complex numbers, you're subtracting complex numbers, you're multiplying complex numbers, and then you're dividing complex numbers. So remember, a complex number is a number of the form a plus bi. Okay, so that's a complex number. So it's a number of that form. All right, so in number 1, you have these two complex numbers. The first one is 9 plus 3i. The second one is a negative 2 minus 8i. And you're adding these two complex numbers. So make sure you are reading the operations very carefully. You know what operations you're dealing with. And then you want to write the answer in standard form. And standard form just means a plus bi. Okay, so in number 1, we have these two complex numbers. So we have 9 plus 3i, and we're adding this complex number to this complex number. Now, adding complex numbers are fairly easy. So you're just gonna add the real parts. So 9 plus a negative 2 is 7, and then you're going to add the imaginary parts, the imaginary terms. And so the imaginary part of this term is a positive 3, and the imaginary part of this term is a negative 8. So 3i plus a negative 8 is a negative 5i. So the answer is 7 minus 5i, and that's standard form. All right, so the first one is 7 minus 5i. Okay, number 2. Number 2, this time you're subtracting complex numbers. So you have 6 minus 2i minus, and then 3 minus 9i. Now there are a couple of ways that you can deal with subtraction. One way is to remember in a previous course that 3 subtract 8 means 3, and then you can always change subtraction to addition problem by following this phrase. So 3 subtract 8 means 3 plus the opposite of 8, and the opposite of 8 is negative 8. So that's one way. So we're going to use that in this case. We're going to use this idea here. So you're going to say that's going to be 6 minus 2i. You're going to change this to addition, just like we did here. And then you're going to take the opposite of every term that's in this parentheses. So you're going to say the opposite of 3 is a negative 3. The opposite of a negative 9i is a positive 9i. All right, so this approach uses this. And now this looks like the previous one. So we're adding two complex numbers. So the real part, 6 plus the negative 3 is 3, plus, and then if you look at your imaginary terms, these two terms here, the imaginary part here is a negative 2. The imaginary part here is a positive 9, so you get 7i. So you get 3 plus 7i. Now another way you could have done this is to use this idea where you had something like, let's say, again this is recall, so let's say you had 7 minus, in parentheses, 3 x minus 2. Let's say you had that. So remember, one way that you dealt with this was to use the distributive property. So you distribute the negative 1. Remember, this is understood to be negative 1. So you distribute negative 1. So you'd say 7, negative 1 times 3x minus 3x, and then a negative 1 times a negative 2 is a positive 2. And so you get 7 plus 2 is 9, so you get 9 minus 3x, or negative 3x plus 9. All right, so you use that idea here. So in other words, if you look at the original problem again, 6 minus 2i, subtract 3 minus 9i, and if I use a distributive property, I could even use a distributive property here, because that's understood to be a 1, and 1 times, this is understood to be 1, and so 1 times all of these terms are these terms, so 6 minus 2i. Distributing a negative 1 here, you get negative 1 times 3 is a negative 3, and then negative 1 times a negative 9i is a positive 9i, and then you're just combining like terms. So the constants, you have 6 and a negative 3, as a positive 3, and your imaginary terms, negative 2i and a positive 9i, as a positive 7i. All right, so regardless of which approach you take, you get the same answer. Okay, number 3. In number 3, you have 6i plus, and then 4 plus 2i. So that's number 3. So 6i plus 4 plus 2i. So again, you're adding these two complex numbers. So this complex number is just 6i, and this complex number is 4 plus 2i. And so you're just going to combine your like terms. So I'm going to put it in standard form though. So since we're putting it in standard form, let's deal with the real part first. So the only real part I see is this 4. So I'm going to say 4. I'm going to add the imaginary parts, the terms. So 6i plus 2i is 8i. So I get 4 plus 8i. So that's number 3. So 4 plus 8i. All right, number 4, you have 16i, subtract, and then 13 minus 4i. So 16i subtract 13 minus 4i. All right, so again, I can use the idea as number 2. I can use the distributive property, or I can just change this to an addition problem. Whichever approach you take, you'll get the same answer. So let's just use the distributive property here. So you're going to say 16i, a negative 1 times 13 is a negative 13, a negative 1 times a negative 4i is a positive 4i. That's a 16i right here. And then combining like terms, I get 16i plus 4i is 20i, and then minus 13, but we've got to put it in standard form, it says. So we're going to say negative 13 plus 20i. That's number 4. So negative 13 plus 20i. Okay, number 5. Okay, so this time, number 5, you have 2i times 3i plus 4. So 2i times 3i plus 4. Now, this time, you're multiplying. So now the operation is multiplication. Now, you got to recall that if you had, let's say, 2x times x plus 5, let's say, in a previous course, when you multiply these two polynomials, you use the distributive property. So you said 2x times x is 2x squared, because x times x is x squared. And then 2x times 5 is 10x. All right, so you use that idea here. So you use the distributive property. So I get 2i times 3i is 6i squared. Remember, I times I is I squared. And then 2i times 4 is 8i. Now, you have to remember that I squared is equal to negative 1. So where we see the I squared, you got to replace it with negative 1. You have to use the fact that I squared is negative 1. You can't just leave it like that. So then you're going to say 6 times a negative 1, because that's what I squared is equal to, plus 8i. So this becomes negative 6 plus 8i, and that's your standard form. So the answer number 5 is negative 6 plus 8i. So negative 6 plus 8i. All right, number 6, you have negative 7i times 4i minus 3. So negative 7i times 4i minus 3. So again, you are multiplying two complex numbers. So 5 and 6 looks like this idea you've had in the past. So you use distributive property. So I'm going to get negative 7i times 4i is a negative 28i squared, because I times I is I squared, negative 7 times 4 is negative 28. And then a negative 7i times a negative 3 is a positive 21i. And then using the fact that I squared is equal to negative 1, I get negative 28 times negative 1 plus 21i. And a negative 28 times a negative 1 is a positive 28, so I get 28 plus 21i. So that's number 6. So positive 28 plus 21i. So 28 plus 21i. Okay, number 7. Let's look at number 7. So number 7. This time, again, you're still doing multiplication, but this time, notice that number 5 and number 6, you had this one factor here, 2i, times this binomial, and so you use the distributive property. Same idea here, except you have two binomials. And so you're going to use, when you do number 7, you're going to recall that when you had these two polynomials, let's say x minus 3 times 2x plus 5, let's say. And so you're going to recall that to multiply these two polynomials, and then they're binomials, so when you multiply two binomials, you use a FOIL method, F-O-I-L. And so you'd say x times x, there's your first terms. Remember, F stands for first. You take the product of the first terms, so x times x is 2x squared. The outer, so those are the terms on the outside, x times 5 is 5x. The inner, so those are the terms on the inside, so negative 3 times 2x is a negative 6x. And then the last, so those are the terms, those are the last terms of each binomial, so negative 3 times 5 is a negative 15. Then you combine your like terms, so these two terms I can combine, so I'm going to get 2x squared minus x minus 15. All right, so you use that idea in number 7. So number 7, you had 6 minus 5i times 3 minus 2i. And so again, you're dealing with two binomials, so you use the FOIL method. So you're going to say 6 times 3 is 18. The outer, 6 times a negative 2i is a negative 12i. The inner, a negative 5i times 3 is a negative 15i. And then the last, a negative 5i times a negative 2i is a positive 10i squared. All right, so don't forget that I times I is I squared. Again, now you got to use the fact that I squared is a negative 1, and you're also going to combine your like terms. So here's what I have so far. I have 18. These two I can combine. A negative 12i and a negative 5i, those are like terms, is a negative 27i. And then plus 10 times a negative 1. Because remember, I squared is equal to a negative 1. Now, 10 times a negative 1 is a negative 10, so I'm going to write this as 18 minus 27i minus 10. And now combining your constants, 18 minus 10 is 8, so I get 8 minus 27i. So that's the answer to number 7, so 8 minus 27i. Okay, number 8, you have 5 plus 2i times 5 minus 2i. Okay, so 5 plus 2i times 5 minus 2i. Notice that when we did this, the binomials are almost identical. See, the first terms are alike, the last terms are alike except for the signs. So the only difference is the middle signs. This is plus, this is minus. And so if you recall, in a previous course, that when you had something like 2x minus 3 times 2x plus 3, all right, so notice the first terms are alike. The last terms, this is negative 3, this is actually they're opposites. So all these terms are almost identical except for the signs. So recall though, when you use the FOIL method, what happened to the outer and the inner. So for example, 2x times 2x is 4x squared. The outer is 6x. The inner is a negative 6x. And then the last, a negative 3 times a positive 3 is a negative 9. Now when you combine like terms, notice that these two terms, the outer and the inner, they add up to be 0. So you just get 4x squared minus 9. And so notice that this is the difference of two squares. So the 4x squared minus 9 can be factored as a product of two binomials in which the middle signs are different. All right, so you're dealing with the difference of two squares. So if you look at this, it's the same idea, so that when you use the FOIL method, you're going to notice that the outer and the inner, for this case, should be 0 also when you add them up. All right, so here, let's go ahead and use the FOIL method, just like we did number 7. So 5 times 5 is 25. The outer is a negative 10i. The inner is a positive 10i. So again, notice that when you're going to add them up, you're going to get 0. And then the last terms of each binomial, positive 2i times a negative 2i is a negative 4i squared. All right, so again, this is going to be 0 right here. So I get 25 minus 4 times, remember I squared is a negative 1. And so this becomes 25 plus 4. A negative 4 times negative 1 is a positive 4, so I get 29. So the answer number 8 is just 29. Or if you want to, you can write it as 29 plus 0i. But just go ahead and leave it as 29. Okay, number 9. Notice in number 9 you have 4 plus 3i. You have this complex number and it's being squared. So 4 plus 3i. Okay, so remember in a previous course that if you had, let's say, 2x minus 5 and you're squaring it, that what that meant was 2x minus 5 times itself. And so notice that these two binomials are exactly the same. So when you FOIL it, when you use a FOIL method, you get 2x times 2x is 4x squared. Notice the outer and the inner. The outer is a negative 10x. The inner is a negative 10x. They're identical. So notice that when you square a binomial, the outer and inner should be the same because the two binomials are exactly the same. And then a negative 5 times a negative 5 is a positive 25. And you combine your like terms, you get 4x squared. There's going to be a minus 20x and then plus 25. So that idea is going to be the same here. So what you're going to do first is you're going to rewrite this as a product of two binomials. So 4 plus 3i times 4 plus 3i. And so use a FOIL method. So 4 times 4 is 16. The outer is 12i. The inner is 12i. So they're identical. Those two terms are identical. And then the last terms of each binomial, 3i times a positive 3i, is a positive 9i squared. Combining your like terms, I can combine these. I get 16 plus 12i is 24i. And then plus 9 times a negative 1. Because remember, I squared is equal to negative 1. So then I get 16 plus 24i minus 9. And then 16 minus 9 is going to be 7. So I get 7 plus 24i. So that's answer number 9. So 7 plus 24i. All right, number 10. Okay, so number 10, you have you have 7 minus 5i squared. So again, just like number 9, you're going to write it as 7 minus 5i times 7 minus 5i. And then you use the FOIL method. So 7 times 7 is 49. The outer, 7 times a negative 5i is a negative 35i. Now, since these two binomials are exactly the same, the outer and the inner should be the same. So negative 5i times 7 is also a negative 5i. And then the last, a negative 5i times a negative 5i is a positive 25i squared. And so then combining like terms, I get 49. This negative 35i and negative 35i is a negative 70i. And then plus 25 times an I squared is equal to negative 1. So I get 49 minus 70i. A positive 25 times a negative 1 is a negative 25. And so I get 49 minus 25 is 24. And then minus 70i. So 24 minus 70i. So that's number 10. Okay, now number 11 and 12, you're dividing. So you're going to have to use the idea of conjugates there. So recall in a previous course that if you had, let's say, 4 divided by 2 minus the square root of 5, that what you had to do here was you had to rationalize the denominator. All right, so notice that the denominator is an irrational number, square root of 5. 2 minus square root of 5 is an irrational number. And so what you wanted to do there is make this a rational number. So that's why they call it rationalize the denominator. And so to do that, what you did was you multiplied the numerator and the denominator by the conjugate of this irrational number. So the irrational conjugate of 2 minus square root of 5 is 2 plus the square root of 5. So you just change the middle sign. But what I do to the denominator, I have to do to the numerator. Okay, just like that. So basically, if you write this as one fraction, you get 4 times 2 plus the square root of 5 divided by 2 minus the square root of 5 times 2 plus the square root of 5. And so let's go ahead and use the distributive property in both cases. In the numerator, it will be the distributive property, and the denominator will be the FOIL method. So 4 times 2 is 8, plus, and then 4 times the square root of 5 is 4 square root of 5. All right, now in the denominator, here's what we get. 2 times 2 is 4. The outer is 2 square root of 5. The inner is a negative 2 square root of 5. So those are going to cancel out. When you add them up, you get 0. And then a negative square root of 5 times a positive square root of 5 is just a negative 5. All right, and so I get in the numerator 8 plus 4 square root of 5 divided by, this is 0 right here, but 4 minus 5 is a negative 1. And so, since that's just negative 1, let's just go ahead and divide both terms of the numerator by negative 1. So I get negative 8 minus 4 square root of 5. All right? And so notice that I did rationalize the denominator, because if you look at negative 1, that is a rational number. So I went from an irrational number to a rational number. Okay? So in number 11, you can use that same idea. So you have 5 divided by 4 minus I. So when you divide complex numbers, you don't want the denominator to be an imaginary number. You don't want this to be an imaginary number. You want this to just to be a real number. So we're going to multiply numerator and denominator by the conjugate of 4 minus I. So the complex conjugate of 4 minus I is 4 plus I. But what I do to the denominator, I have to do to the numerator. So then I get, I'm going to write this as one fraction now. So I get 5 times, in parentheses, 4 plus I. Now in the denominator, let's go off to the side and multiply this out. So I get 4 minus I times 4 plus I. All right, so if I use the FOIL method, 4 times 4 is 16. The outer is 4i. The inner is a negative 4i. And then negative I times I is a negative I squared. All right, just like before, if you notice, this looks like the difference of 2 squares, so this is going to be 0 right here. So I get 16. Now be careful with this. So that's 16 minus, and then I squared is a negative 1. That's what you have. So 16 subtract a negative 1. But remember, 16 subtract negative 1 means the same thing as 16 plus the opposite of a negative 1. Change this to addition. So you get 16 plus 1, which is 17. Okay, so the denominator is 17. Now go ahead and distribute the numerator, though. Just distribute, get rid of the parentheses in the numerator, so use distributive property. So I get 5 times 4 is 20, plus 5 times I is 5i, over 17. Okay? Now the directions did say write in standard form. So you're going to write it as two fractions, a plus bi. So then you're going to say 20 divided by 17 plus 5i divided by 17. Okay? So 20, so the answer is 20 divided by 17 plus 5i divided by 17. Okay, now number 12. I'm going to go ahead and do the work here. So I'm going to say see work on other sheet, other page. All right, I'm going to go ahead and do the work here. So here again, this is an imaginary number. You want this to be a real number. So you multiply numerator and the denominator by the conjugate. So the complex conjugate of 3 plus I is 3 minus I. But again, what you do to the denominator, you have to do the numerator. So then this becomes, right here, if I write as one fraction, this becomes 7i times 3 minus I. So 7i times 3 minus I divided by, and then this becomes 3 plus I times 3 minus I. Okay, so if I use distributive property in the numerator, I'm going to get 7I times 3 is 21I, and then 7I times a negative I is a negative 7I squared. So that's what I have in the numerator so far. The denominator, if I use a fall method, 3 times 3 is 9. The outer, 3 times a negative I is a negative 3I. The inner, I times 3 is 3I. And then the last, a positive I squared times a negative I squared, that's a negative, positive I times a negative I, that's a negative I squared. So now what I have is this. I have 21I in the numerator, so 21I minus 7 times I squared is a negative 1, so replace I squared with negative 1. The denominator, this is 0 right here, so I get 9 minus, and then I squared is a negative 1. So 9 subtract a negative 1. And let's go ahead and simplify both numerator and denominator. So I get 21I, a negative 7 times a negative 1 is a positive 7, and then 9 subtract negative 1 means 9 plus 1, so that's 10. Now let's go ahead and write this in standard form. So if I write this in standard form, I'm going to get 7 plus 21I, so 7 divided by 10, plus 21I divided by 10. Okay, so that's your standard form. So the answer is 7 divided by 10 plus 21I divided by 10. All right, so that's number 12. Okay, number 13, same idea. You're gonna, right now you have this imaginary number. You want this to be a real number. So notice when I did this, I went from an imaginary number to a real number. See, 10's a real number, not an imaginary number. Okay, number 13, you're going to multiply both numerator and denominator, oops, that's a 2, plus 3I, times the conjugate of the denominator. So the conjugate of 2 plus 3I is 2 minus 3I. Again, so what you do to the denominator, you have to do to the numerator. So then I'm going to write this as one fraction instead of 2, so it's going to be negative 5I times 2 minus 3I. Alright, and then the denominator, you have 2 plus 3I times 2 minus 3I. Okay, so this is going to become, if I get rid of the parentheses, this will become negative 5I times 2 is a negative 10I. A negative 5I times a negative 3I is a positive 15I squared. Divided by, and then using a fall method here, 2 times 2 is 4. The outer is negative 6I. The inner is a positive 6I. And then the last, 3I times negative 3I is a negative 9I squared. So then this becomes negative 10I plus 15 times a negative 1, because I squared is equal to negative 1. The denominator, notice that the outer and the inner add up to be 0, so you have 4, subtract 9 times I squared, remember I squared is a negative 1. So then, in the numerator, I get negative 10I, 15 times negative 1 is a minus 15, subtract 15, negative 15, and this becomes 4 plus, well, let's go ahead and write this. A negative 9 times a negative 1 is a positive 9. And so, I'm running out of room here, and so I get negative 15 minus 10I divided by, and then 9 plus 4 is going to be 13. And so if you write it in standard form, the answer is going to be negative 15 divided by 13 minus 10I divided by 13. Okay? All right, number 14. All right, so 14, again, you're dividing complex numbers, so you want this right here is imaginary. You need it to be real. So notice I went from this imaginary number to this real number, 13, in the denominator. So you have 4 minus 3I, divided by 3 plus 4I. So you can multiply both numerator and denominator the conjugate of the denominator. So the complex conjugate of 3 plus 4i is 3 minus 4i. What I do to the denominator, I do to the numerator. Now notice that in the previous three problems, the numerator was just one term right here. So now you see the numerator is two terms. So in both cases, you're going to use the FOIL method. So I get 4 minus 3i times 3 minus 4i divided by, and then 3 plus 4i times 3 minus 4i. All right, so again, in both cases, you use the FOIL method. So let's look at the numerator. 4 times 3 is 12. The outer is a negative 16i. The inner is a negative 3i times 3 is a negative 9i. And then the last, a negative 3i times a negative 4i is a positive 12i squared. The denominator, notice those are complex conjugates of each other, so the outer and the inner should be 0. So 3 times 3 is 9, that's your first. The outer is a negative 12i. The inner is a positive 12i. And then the last, a positive 4i times negative 4i is a negative 16i squared. All right, now combining like terms, I get 12 in the numerator. A negative 16i and a negative 9i is a negative 25i. And then plus 12 times I squared. Remember, I squared is a negative 1, so go ahead and change it now. I squared is a negative 1. The denominator, this is 0 right here. So I get 9 minus 16 times I squared, and I squared is a negative 1. So then in the numerator, I have okay, so this right here becomes 12 minus 25i, and then a 12 times a negative 1 is a negative 12, divided by, and this becomes 9. A negative 16 times a negative 1 is a positive 16. So then notice that the constant terms up here combine to be 0. 12 subtract 12 is 0. So you're just left with the negative 25i in the numerator, and the denominator is just 9 plus 16, which is 25. So before we go on, notice I went from a imaginary number to a real number. But also notice, and you want to simplify if you can, that negative 25 divided by 25 is a negative 1. So that's just a negative I. All right, so there's your answer, negative I. Okay, now in 15. So in 15, you just want to perform the indicator operation. So you want to add, divide, and divide. But you want to simplify, basically. So you're going to simplify these, and you're going to write it in standard form. So let's look at number 6. So number 15, you have 6 square root of a negative 9 plus 2 square root of a negative 16. All right, so notice that the square root of a negative 9, remember, is just 3i. So that's 6 times 3i plus 2, and then the square root of a negative 16. Simplify square root of negative 16. That's just 4i. So 6 times 3i is 18i, and then 2 times 4i is 8i, and you can combine these, and so you just get 18i plus 8i is 26i. All right, so that's number 15, 26i. Okay, number 16, you have 4 square root of a negative 18 plus 3 square root of a negative 8. Now, 18 is not a perfect square. 9 was a perfect square, 16 was a perfect square, so that's why you were able to simplify it very easily. But these are not. So you want to go ahead and simplify the square root of a negative 18. So let's go off to the side right here and then simplify that. So the square root of a negative 18. So I can write the square root of a negative 18 as the square root of a negative 1 times the square root of 18. And I know that the square root of a negative 1 is I. And I know that the largest perfect square that goes into 18 is 9. So I can write this as the square root of 9 times 2. Because 9 times 2 is 18. I also know that the square root of 9 times 2, the way I've written it, is the same thing as saying I times the square root of 9 times the square root of 2. And I note that the square root of 9 is exactly 3, because 9 is a perfect square. So I get 3i square root of 2. 3i square root of 2. Now, if you want to rewrite it so that the i's behind the radical, you got to be careful. Make sure that it looks like this. Make sure that you can tell that the eye's not under the radical. Sometimes when you put it too close, it kind of looks like that, where the eye's underneath. Okay, it's not supposed to be underneath. Okay, it's supposed to be on the outside. So that's why sometimes it's a good idea to just write it as 3i squared root of 2, where I is between the 3 and the radical. All right, so that's the square root of a negative 18. So this right here becomes 4 times 3i squared root of 2. 3i squared root of 2. All right, now let's look at the square root of a negative 8. So the square root of a negative 8, we use the same idea. So that's the square root of a negative 1 to the square root of 8. A perfect square that goes in an 8 is the largest, is 4. So it becomes, and this is I, so it becomes I times the square root of 4 times 2. 4 times 2 is 8. I'm going to rewrite this as I times the square root of 4 times the square root of 2. The square root of 4 we know is 2, so it becomes 2i squared root of 2. Alright, so I'm going to put this here. So that's 3 times 2i squared root of 2. Okay, so then 3 times 4 is 12, so it becomes 12i squared root of 2. And then 3 times 2 is 6, so that's plus 6i squared root of 2. Now these are like terms. See, I squared root of 2, I squared root of 2. So there's 12i squared root of 2's here, and then there's 6i squared root of 2's here. So altogether there's 18 of them. All right, and so that goes here, 18i squared root of 2. Okay, number 17, you see this square root of a negative 27, you can do it just like you did these right here. So you're going to kind of figure out what perfect square goes into 27, which is 9. So you're going to say square root of a negative 1 times square root of 27. So that's I, square root of negative 1 is I, and that's going to be square root of 9 times 3. And so that becomes I square root of 9, square root of 3. And then square root of 9 is 3, so that becomes 3i square root of 3. So 3i square root of 3. All right, so that's going to go here, right here. So then this becomes 4 minus 3i square root of 3 divided by 12. All right, now what you need to notice is this. If you look at these numbers here, 4, 3, and 12, 4, 3, and 12, they're all divisible by 1 only. Okay, so you cannot reduce those 3 at the same time. Now, if the directions didn't say anything about standard form, then you can leave your answer like this: 4 minus 3i squared root of 3 over 12. But the directions said write it in standard form. So what you got to do now is this: you got to say 4/12 minus 3i squared root of 3 divided by 12. So 4/12 minus 3i squared root of 3 divided by 12, and then reduce these. So your answer is going to be 4/12 is 1/3 minus, and then 3/12 is 3 into 3 is 1, 3 into 12 is 4. So minus I squared root of 3 divided by 4. Or you can say 1/3 minus 1/4 I squared root of 3. Does not matter. All right. And let's get this right here, square root of negative 24. So square root of negative 24, that's going to be square root of negative 1 times square root of 24. The perfect square that goes into 24, the largest, is 4. So that's square root, so that's I here. Times the square root of 4 times 6. So that's I square root of 4, square root of 6. Square root of 4 is 2. That's 2, so that's 2i square root of 6. Okay? So that goes here. So this becomes negative 6 plus 2i square root of 6 divided by 24. All right, now notice that, again, you want to write in standard form. So if they didn't say anything about standard form, you could leave it like this, although you have to notice that negative 6, 2, and 24 are all divisible by 2. But since they did ask you to write in standard form, then the next thing you're going to do is just write it in 2 separate fractions. First, you're going to say negative 6 divided by 24 plus, and then 2I squared root of 6 divided by 24. All right, so negative 6 divided by 24 plus 2I squared root of 6 divided by 24, and then reduce. So that's going to be negative 6 over 24 is, they're both divisible by 6, so that'll be negative 1/4. Oops, sorry, negative 1/3. Nope, 18. So they're not divisible by 6, but they're divisible by 2, so it'll be negative 3 divided by 12, which is reducible, so that is going to be negative 1/4. Alright, so I'm not sure what I was thinking, so, but they are divisible by 6. It's because 6 times 4 is 24. I'm not sure what I was thinking of, but negative 1/4. And then plus, and then these are divisible by 2, so it'll be 1 divided by 12. I squared root of 6. Alright, so there's a lot of stuff here, but that goes, this right here, goes here. So that's negative 1/4 plus, and then 1/12 I square root of 6. Okay? Alright, so that takes care of the key for this one, the key to this worksheet. It's pretty involved, a lot of problems here, and it just became a little bit messier around this area. Alright, so that takes care of this worksheet.